Hey guys, welcome to my channel. As usual, we will be learning a complex software engineering concept in simpler words. Today's topic is Elasticsearch internals. Many of us might have worked on Elasticsearch, but are we aware of the internal workings of the same? How does Elasticsearch actually store data to provide us with the real-time analytics? What data structures and algorithms empower them? So, take a deep breath, time to open up this black box. Let's start with the basics. As you might know, inverted index is primary data structure of Elasticsearch. In layman terminology, whenever a document is saved, a mapping is created between all the terms versus the document. This data structure is the core of the search engine and makes lookup possible. In case you aren't aware of this, you can Google it up. There are thousands of articles on the same. Now, once the basic is done, let's deep dive into the much more interesting parts. A document is mostly a JSON structure containing many fields. Each JSON field has a separate inverted index data structure. So, more the number of fields, more the number of inverted index present in your system. And yes, you guessed it right. That's why there is a limit of 1000 index fields. Some people have the misconception that inverted index is just the mapping of word and document IDs. But it also contains many more information, like the number of times the term occurred in the document, length of the document, etc., which ultimately helps it in defining the relevancy of the documents and thus the score. Now, the next concept is by far the most important concept. Inverted index is immutable. Yes, you heard it right. But why is that so? Because no updation means no cache invalidation. Also, no mutation means no locking the databases for avoiding the race conditions, which finally means faster databases. But if the inverted index is immutable, how do we add more data? The answer is we create a new inverted index every time a document is being saved. But that would be very costly, right? So Elasticsearch buffers the documents for some time and then create one inverted index for all those documents. This inverted index is called segments and this sometime is called refresh time. This refreshing time is usually of 1 second, since every document takes the minimum of refresh time to get indexed. That's why Elasticsearch is called near real-time analytics. The above optimization might save us some cost, but again, will it be scalable? Each inverted index disk sync takes considerable resources, and because of this bottleneck, Elasticsearch couldn't have scaled to support millions of documents. So, how did they fix it? Yes, caching. Instead of directly saving in the disk, add it to a cache first and then flush the cache later in one go. This time is called flush time. But what if my Elasticsearch fails in between? Where will my cache data go? Will I lose that forever? Probably yes, but Elasticsearch has a solution for that as well. The solution is translog. Whenever a segment is being inserted in the file cache, all the operations are being recorded in a lightweight file as well. So, in case the system stops in between, data can be recreated with this translog file. That's how Elasticsearch manages our inverted index for us. But there is one more data structure without which Elasticsearch couldn't have worked: field data. What if we want to know which terms are present in which documents? Via inverted index, it would be very time consuming, right? So that's why reverse mapping is also kept, called field data. This is again kept in memory. Again, will that be scalable? So Elasticsearch keeps it in disk as well as doc values. That's it for today's video. I hope this video was useful to you. Please feel free Please feel free to ask any queries in the comments below. Thank you.